Real easy.
We set up a time to meet prior to when we start. When you show up 3 minutes before you start,
I was here. I was trying to get this thing situated. It sucks.
I show up typically an hour before the show.
Yeah, tell the people why their time is invaluable.
It doesn't automatically unmute us, though, does it?
it did.
it? Oh, I unmuted myself, but it unmuted you guys. Okay, so that's kind of cool.
Myself as well.
You got to be careful with this because we like have a conversation before, and Adam just hits live. Like,
Yeah, but it goes to the music, so
it
you
does. But it freaked me out for a minute. I'm like, oh, okay, we're live.
So I sent Housh a link.
Cool.
We haven't talked to him in a while, you know.
It has been a while. It's been a very long while.
So
Very long while. So welcome to the Overtime Show. Bill is not here today. He's doing dad stuff, picking up his kid from the airport.
Yeah.
Or granddaughter, I think, from the airport.
Step granddaughter.
It's granddaughter. There's no step in a family. So,
dude,
come on, bro. I don't have any real brothers or sisters. They're all step or half. There's no such thing as half or step. It's just fucking brothers and sisters.
Yeah, I guess that's true. Oddly enough, though, my mom got remarried years ago, right?
Yeah.
And then she got a divorce. So my stepdad had 2 kids that were not by blood.
Okay.
And they just kind of disappeared. And the one found me on Facebook. Right? He's got like such a common name. It's kind of like, you know, what do you think? Like, think of a super like John Smith. He's got a name like that. We would never find anybody if you looked him up online. You know,
just because there's so many.
Yeah.
So, how long were you around them?
I don't know. Good, solid, probably 10 years ish or more.
So that's a family relationship. Oh, sorry, I hit it at the same time you hit it. So
yeah.
What's up, Housh?
Look at this guy, all serious and all.
Yeah, all fancy.
That's an executive freaking chair you're in right now.
I feel like you're on Trump's airplane. Like it's a big, giant, plush. I bet you there's like a button and like peanuts pop out of the handle. Like, and he's got a little snack, like a soda pops up out of the other side.
This is not like the normal room that he's usually streaming from.
Nope, no. I'm not in my office. I'm sitting in my living room.
There you go.
Oh, nice.
Actually, didn't you just do a post today, Michael? I didn't get a chance to look at it in detail. You did a post earlier. Is that your setup or
his Franken System?
Franken System, right?
Yeah, that's all my controls. I'm cleaning up my like interface that I use to control custom parts of it, and then I have like an array of temperature sensors and stuff, and so it shows me sort of what's going on with the system. Getting ready to add more since I got my boiler up and running, so I need to get some pump wattages and different temperatures for water temps and stuff like that.
So let me ask you something, because I know you have an evaporator coil which is in your return right now. Is that right?
Correct.
And you have it's like a basically like a blower motor. It's an air handler with nothing in it.
It's a hydronic air handler, so it has a heating coil. in the air handler. And
Right.
so the long-term goal is to have hydronic reheat
Mm.
and for dehumidification, which is why the coil's in the return side, so my hot water coil is after it. And there's also a coil bypass, which I use to control air across the evaporator coil, because I run at total airflow is at like 600 CFM per ton.
Nice. So how does that that air handler, like, what kind of fan power does that thing have? Because if you're pulling through that evaporator coil, I know you have a coil bypass on that, but like, you know, you're using most of the same duct system, right? You just kind of reconfigured it near the equipment. Or am I wrong?
Yes, you are correct, but it was sized pretty well. My return is probably on the undersized, or at least like my return grill for the amount of airflow that I'm running. It can be a little bit noisy when I'm running at full tilt, so I need to that's on my list of things to do. It's just sort of low priority.
So why have the bypass on the evaporator and the reheat coil? Do you think the bypass is not good enough for dehumidification, or I guess the reheat?
So the bypass is primarily so that I can run higher airflow, but I can control the airflow across the coil. I still struggle at times with humidity control because my house sucks.
Yeah.
And it's a challenge to fix the house. I mean, I'm trying to, you know, work through air sealing and all that stuff, but there's just some challenges that are hard to overcome.
And maybe I missed it. What are you using to engage, let's say, the reheat coil and stuff? Like solenoids or modulation? What's it going to be?
Well, I mean, currently nothing. The plan is I will write my own software, probably. Like, for the most part, I try to have the thermostat be the brain, so that like if the software I create goes down, it sort of does the right thing. But so I'll have a signal from the thermostat that says, hey, I need dehumidification, and then I'll trigger some automations that'll bring on the pump and try to target, like, so my ideal scenario would be to target like a certain supply air temperature.
Okay.
And so so
like,
I'm
would
not
that be would that be like, are you trying to, like, in my head, I'm thinking like, if you're trying to dehumidify, I would try to, my supply air temperature target would probably be close to the same as the return air target, as long as there's not a big difference.
Yeah, I'll do it similar to what I want the house to be, right? Like, so I'll probably target like a 75-degree supply air temperature or something like that.
Yeah.
I had my what do you call the ICM whatever voltage monitor?
ICM,
monitor?
ICP or ICM?
ICM voltage monitor, whatever thing.
Phase,
it shut my stuff down today. And I've had this happen on I have two of them. I have one indoor, one outdoor. And my outdoor one, like a month ago, I went out there and I checked it, and I never realized you had to calibrate them. So you got to go in, you got to check the voltage, calibrate them. I found it was like 4 volts off or something like that. So it was going off on high voltage, and it wasn't. It was like right at the threshold. So anyways, I did that. Well, I never did my indoor one because it had never been a problem, and that one went off today. So my voltage was at 240, 250 volts is what the actual measured voltage was, but the ICM was seeing 254. So I had to go in and calibrate it, adjust it down, but still it's crazy, dude. My voltage swings so much here depending on the demand and the load. Like you'll be at 240, 238, and then all of a sudden you'll be at 250. Just freaking bonkers.
I wonder if it's like it seems that the inverter outdoor units have more of a struggle or problem than I've had with like blower motors or whatever kind of deal, right?
That's
like
a good question. Yeah. I mean, I haven't had any problem with my equipment. My equipment's been humming along. It just, my voltage monitor shut it down. That's the only problems I've had is the voltage monitors, which is doing its job, you know?
Right.
So,
Yeah. Well, I guess what I mean is like the failure rates of them, right?
Gotcha.
Not that your specific instance is having a problem,
Yeah.
but I know people in areas that do have a lot of voltage fluctuations have more of a problem, it seems, with outdoor inverter boards than they
Right.
have with indoor.
Yeah. That makes sense, you know, because there's a lot more going on there with the inverter and it's probably a little more sensitive versus just the indoor unit with basically all it has is a board and, you know, your ECM motor, and that's it.
Yeah, and it seems like whatever they've made some, updates and changes versus early generation variable speed motors, they're kind of more reliable, like knock on wood. It seems
And I would say too, yeah, I would agree with that. And then I'd also agree with, you know, sizing everything right. And I'm well under the thresholds, you know, I don't even remember what my static is, but it's like 0.3 or something. Like it's really, really low. So, you know, you're not putting any added stress or anything on there. So,
and we used the fairly, like you had a, all we could fit was a 20 by 20 filter in there. I wanted to originally go bigger, but you just had like a height constriction in that, you know?
Yeah. I really wish I could have fit bigger than MERV 13 too, but you know, we wanted to keep the pressure drop way low and obviously size wise and everything, but yeah.
I'm surprised you had really high electric bills previous to changing your system.
Mm-hmm.
And it's driving me nuts that you're not looking at your bills right now and you're not telling me like, I want to know how much your bills have dropped on a monthly basis.
First off, you can't look at that because our electric rates went through the roof since I initially did everything.
Yeah,
so
but
you gotta
look at the usage.
Yeah, you look at the usage. But Adam wants to see he's always asking me the dollar amount. I'm like, I can tell you
it was just like how much you were spending like $700 or $800 or $900 a month.
At times I'd hit like $800. I'm nowhere near that anymore. But honestly, it's on auto pay. It just freaking pops out. So I've just been so busy I haven't even paid attention to it.
Well,
but my kilowatt usage did go down, but you also have to remember that there's things about my system too, like it never shuts off, right? So, but it's more comfort than, you know, I'm saving a little bit of money, but then at the same time, we're a lot more comfortable because we don't have the uncomfortable spots in the house anymore. So
yeah, that's honestly why looking at energy data or folks that rely on that drive me nuts a little bit, because comfort costs money, and like especially like removing moisture from a building is expensive, right? Like, I mean,
but he's relatively dry anyway, so like we kind of pushed the envelope a little bit, and if I remember correctly, I can't remember exactly what we designed for. I want to say it was like more like maybe a little over 450 CFM per ton.
Yeah.
And you were saying in the summertime that there was times where your relative humidity would get still a little bit low. So I'm like, crank that thing up. Just put it on the highest freaking fan speed.
Yeah, we have the fan speed maxed and it runs. Well, it doesn't run max in the off. Well, it's not really in the off cycle very often, but I just have it running on low speed when it's in standby mode or whatever. But the indoor fan never shuts off. It hasn't shut off since I installed the system. It just runs all the time. But
I think one of the things we do sort of wrong in our industry, or one of the problems with new inverter-based equipment, is the fact that the fan slows down. I think we should always run the fan at a higher speed, and I get why it's done or whatever, but that's sort of why I went with the coil bypass design on my system. But I also have, like, you know, my ceilings are 14 feet high, and like, so I have a lot of volume.
So you're saying not like you're not talking about the same thing that Chris is saying as far as slowing the fan down during the cycle off. You're saying leave the fan on high with the inverter as the compressor ramps up and down.
Well, right? I think you should do it in the off cycle as well.
for air
to
circulation.
promote mixing and dust entrainment in the filter and better throw out of the registers. Now, some of these things matter less the tighter the home gets.
Yeah.
But that said, I think that like when you look at what ASHRAE recommends for air changes across a filter, or, you know, air changes in a room, they are way higher than what we provide in a typical HVAC system. And everybody just focuses on how the equipment performs, not really everything as a whole, right? And so that's where I feel like we've gone down this path of focusing on making sure the equipment runs as efficiently as possible, you know, whether it's the DOE or the equipment manufacturer that's like pushing that.
Yeah. Well, they want to see the numbers because the marketing department helps to promote their SEER ratings and all that crap, right? So they want to see most efficiency, least electrical consumption, and they want you to be comfortable, but you know, they're just kind of letting people figure that out on their own. So for instance, at my house, we run ceiling fans all the time to help with the air circulation. So that way, when we're not in full speed, right, we've got ceiling fans helping to mix, and those ceiling fans are not efficient. You know, I mean, they're new-ish, but they're not ECM motors or anything like that. You know, I mean, they're just whatever. I mean, maybe they're ECM motors. I don't know. I have no idea what's in a freaking ceiling fan, but those things are running. So, you know, I'm sure that's adding to it.
That's like another thing too that I'm curious if ACA is going to address as far as like, because like inverters and multiple stage equipment, like if you look at manual T, how old is that? It's like 40 or 50 years old, right? And if you're sizing your grills on max airflow, what kind of happens as far as throw and spread if you have an inverter? You know, everything.
Well, manual LLH, the low load homes or whatever, that's where they discuss nozzle style diffusers or whatever, right? Because they work a little bit differently than a traditional diffuser does. And I don't remember exactly all the details or whatever of that, but that's sort of an interesting way of handling lower airflows based off, you know, the volume of a room or a building or whatever. But that's also where, like, in my mind, it still seems like a little bit of a Band-Aid solution versus something that has a constant airflow volume that's different from what is crossing an evaporator coil, and the coil bypass sort of solves that.
I would say too, another thing is I knew what I was getting into. I knew that we were kind of aggressive in our sizing, and I knew that, you know, there was going to be times when, you know, I wasn't going to be able to get my house to 62 degrees like that, right? Because we sized it appropriately and then went a little aggressive. Instead of going with a 3-ton, we went with a 2-ton because it was like right there. But also tightening the envelope on the house. And the theory behind all that was, again, because I knew what I was getting into, right? We discussed this also. We knew that eventually, if I really have issues with it, we're going to bring the house to the equipment essentially, right? So I'm going to keep air sealing. We're going to bring the envelope down, you know. And there's things that I realize as I'm going through my house. Like, for instance, when we cook things in the house now, it's like, dude, the smells go through the freaking house because we've tightened up the envelope so much, right? The air changes in the house are so much lower. When my wife cleans with chemicals, I go crazy because I don't understand it. I think it's just something about what she does, but like she'll be in the bathroom scrubbing with bleach, and I'm like, what? And I'll walk in the garage, and I'm like,
I mean, if you think about everything that was happening in your house before, which the original plan was to add ventilation to your house,
yeah,
like
and
that's
we still
what
will, yeah.
That's like something that was on, you know, that was in the design, right?
Yeah.
But if you think of what was happening before in your house, like your house was leaky to start off with, and you're mostly hot, right? So you're leaking air in from the attic, but then also you had a ton of supply duct leakage in the attic. So you're taking air from your house
We're
and
making
you're
it negative. Yeah.
making the house negative, and you're sucking in all this outside air. So it was like natural HVAC induced infiltration or ventilation, let's call it, that was, you know, made it probably less severe when she cooks or uses bleach in the house, you know.
But what I'm curious, the point that I'm trying to make is that, especially with the big box pushers, the home service companies that are just pushing crap down people's throats, you know, if they jump on the home performance bandwagon and just start, you know, just, oh, let's tighten up the house, let's do this, and we'll sell them this, and you're going to love this. They're going to get so many people complaining about these kind of things. Now, you know, when you clean the bathroom with bleach, your kid 3 rooms over is going to smell it, you know, I mean, because it just doesn't leave the house. And that's the kind of stuff.
I think there's low odds that they succeed at home performance type of stuff because it requires
good point,
more thought and stuff, right?
Good
like
point.
You know, I mean, I think that they may dip their toe in the water and quickly realize that it's not for them or something, or they'll start screwing up things that cost real money and you know, then get out of it. So I don't know that I'm not saying there aren't big players that could succeed at it, but I think there's much higher odds that it's like a better game for smaller contractors to be in, really.
For sure. And also, you know, you're not going to get the big, well, unless regulations require better home performance, which that is inevitable. The regulations are going to require people to tighten up houses, but they're not
existing,
like crazy tight,
right?
So.
You know, like, so that's all a production builder problem.
True.
Almost, right? You know, I mean, or it may affect the production HVAC installers by having to pass, you know, duct leakage tests and things like that. But actually, the enclosure portion or whatever is going to be on the builder and other subcontractors.
And in all reality, those regulations, even though, you know, I am in California where, you know, pretty much if you can think it, they're going to make it a rule or a law. But at the same time, money still does rule here. And, you know, you get the big giant builders and they're spending a lot of money, and, you know, that would dramatically affect them. And basically those rules aren't getting passed right now because they have a lot of influence in that kind of stuff.
It's also hard with the big production builders that have stuff all over the country, right? They're able to make enough in the areas that don't care about this stuff to pay some lawsuits in the areas that they do have problems, right? You know, it's really a hard problem to solve, I think, because in reality, it needs to be like driven by the consumer or whatever, instead of like these code enforcement type of things. And
correct.
It really just either the consumer's not really driving it, or not enough people are shouting loud enough, and the code stuff just doesn't always get enforced or whatever, you know, because even in areas that do have better codes, they're still getting homes built that, you know, are getting mold in them in the first couple years, and HVAC stuff's still not sized properly. And so, you know, it's just this shit show, really. I mean,
pretty much. Yeah. No, it is.
Do you think that like a lot of this stuff, I mean, maybe I'm wrong. Maybe we're just hearing about it more now because of the internet and all that. But like a lot of these, like the mold issues and indoor air quality things, like I didn't think that was a big thing like 20 or 30 years ago. Like, and is that because of like just the way the houses were built and they were able to dry out and they were, you know,
they were probably a lot leakier. Right.
Yeah.
Like there's actually some of these codes and stuff are probably doing a good job where the houses are tighter. It's just not all the other trades have
caught up to it.
Yeah. And or they're not the ones that get in trouble for it. Right. Yeah. You know, I mean, like it could be, but this is also me speaking as an outsider because I'm not like, you know, I've never been sued for anything like that or whatever, you know what I mean? Like, but just, you know, gathering information of what I sort of see out there or whatever. And there's more like natural disaster type of things happening, right? You know, like, so a lot of the, say the Louisiana or Florida stuff that get a lot of hurricanes and stuff like that, that can, like, a house that's been on a flood or whatever is way more susceptible to problems for the rest of its life.
I would also say though that we are more litigious these days, right? People are more ready to make lawsuits. That's the first thing on everybody's mind is who can I sue when something happens. The next thing is that people are more aware of things because of the media that we have, social media, you know, and the constant 24-hour news coverage on every channel for whatever reason. People know about mold. They know about these things. I think that a lot of these problems did exist, and I think people just dealt with them. Maybe not like insane amounts like this, but I think for a good part of it, people just dealt with it. It was just something. I mean, it was normal.
More health conscious now.
Yeah,
right?
and you know, I mean, people would be like, yeah, my house is always muggy and like, you know, icky, and it has that smell to it. You know, the whatever mildew smell.
I do think that like by them, you know, changing the codes and requiring tighter houses, I think it's making it easier to screw up a house. You know what I mean? Yes. Like if everyone doesn't do their job correctly, it's becoming much more easier to really screw up a house.
I understand that you have to start somewhere, and I understand, and I don't want to say that I agree with the way that they pass codes and regulations, but everything that happens here in my state, they pass a regulation and then figure out how to implement it after the fact. They just know, you know, we're going to set a standard. Your house needs to be this tight, and then figure it out.
Well, it's also like, what other way is there to do it, right? That's where I'm saying, like, a lot of this stuff is a hard thing to think about or solve. Like,
to your point, it needs to start with the new home construction. That's where it needs to start. It needs to start from the ground up. Build it up, build it tight, put the stuff in there. You know,
it's just such a long game plan, like, depending on what, you know, you think of, you know, what we need to do from an energy standpoint or whatever, right? Like, there's lots of new homes built, don't get me wrong, but what we're doing now is like going to take 15 or 20 years to see any sort of, I don't know that payback's the right term, but
because you're not, like we were kind of talking earlier, you're not going to see that payback. Prothermal Refrigeration and HVAC asked a question earlier, and he said, how is ECM more efficient than a regular motor? Does it save enough money to cover the ECM replacement? And to that point, you know, we have all this energy efficiency stuff, and it's going to save us money. I think that it shouldn't be sold kind of like what you were saying, Housh. It shouldn't be sold as it's going to save us money. It's just more efficient. It's going to make it more comfortable. It's going to save a little bit of energy, but the return on investment when that motor fails because it was installed improperly, no, you're not going to save money. You're going to lose all your money.
I don't think like the government's not mandating ECM motors on residential equipment to save us money. They're trying
to also don't care about its longevity. I don't know, right? You know, it's all about the electric grid, or, you know, like, it's not at all about what we care about or whatever, but, you know, that's the way that the world works too.
Yeah. We tend to throw those, you know, like I can think of here in California, you know, we're always adopting these energy codes, and I can think of, you know, big companies helping to promote and giving rebates to people that would let technicians come out and do, you know, energy efficiency upgrades on their house, and the state would subsidize that, right? And give the homeowner a portion of that money. And those energy upgrades, like, were basically go in and check the refrigerant charge, make sure the refrigerant charge was right? So they would go to everybody's homes and they would adjust the refrigerant charge, right? They weren't necessarily making the system. They were adjusting the refrigerant charge for the shitty airflow is what they were doing, but they still had shitty airflow. They were just adjusting the charge. Like, oh, your charge isn't right. That's the kind of stuff we're doing. We're kind of going about it backwards. Like, we're just addressing
that's kind of why, like, it's crazy that we keep changing efficiency standards and doing all this stuff, jumping
what
through
is the
hoops.
SEER 2? That's so freaking
Because like there's no policing of how equipment is installed or commissioned. So like until that actually happens, what is the point of increasing the efficiency of equipment? Because it's just going to continue to be installed like crap, right?
Well, it's also what's the point if you have to add ancillary equipment to do all the work that needs done as
such
well.
as like a dehumidifier or something like that.
Yeah, you're saying like if you're going to install a 20 SEER and the 20 SEER is not capable of dehumidifying, you have to add another compressor.
Yeah.
Via dehumidification.
Or it's like the push of all the mini splits and stuff. And sure, they're efficient, but they are like mostly garbage, you know? I mean, and so, but they get marketed as being so efficient and everything. And so that's where it's just a challenge of balancing all the things. And when you're like, you know, in the industry like we are and sort of understand more than the average consumer about all this stuff, it is just night and day of how to sort of approach those conversations, at least, you know, from I'm all for energy efficiency, don't get me wrong, but there's a point and a trade-off that it just seems sort of silly without utilizing like a different technology than what we do. Like, you know.
Well, I mean, Alex Meany, I've seen him talk about it multiple times where he's like, there was a time back in like the early to mid 90s where you could sell a high efficiency condenser, right? And it would actually pay itself off it was silly not to buy it, but like that time is not here. The difference in price in a high-end system versus a, you know, whatever, a 13 SEER piece of equipment is so large, like the payback's just not there anymore, you know? And even
the equipment, it all caught like we used to put full systems in the 90s for $2,500, right? Or something, right? You know, like and maybe the high efficiency was 3,000 or something like that. Cost difference was tiny compared to what it is now, sort of like what you're saying.
Yeah.
And there also wasn't 8 million choices. You could get a 10 SEER or a 12 SEER. Those were your choices.
So like, for instance, you know, what you did to your house, Housh, was like, if you were to sell that to a customer, what you've done, and I realize it's not practical, but what do you think that would cost a customer if you were to sell what you're doing to your house, like with all your tinkering and everything like that?
Well, I mean, I wouldn't do it because it would be like a big babysitting project. Like, but not, I mean, it wouldn't be that much more than a regular system. I mean, like hold
on a second.
$1,000 more.
Pump the brakes. No, think about how much time you have spent in
thinking
all the different motorized dampers, aligning them, fitting them together.
Yeah, but that's not needed, really, right? That was for me to tinker. It's not really needed. Like, you could get away with way less dampers, and you know, that was just for me to put it in a lot of different scenarios to sort of learn how it was going to function. But in reality, you don't need hardly any of that. Like, you would need one damper, and much smaller than the dampers that I used. And, you know, as long as you set up some stops or have a hand damper that you can use to balance it all, it would work fine.
So, the point that I was making is if I was to sell my system to, you know, what I did to my house, and there's a lot of thought that went into it, a lot of time, and it was unnecessary. Of course, there's a lot. I didn't have to run my crap in Unistrut and line like that. That's all just, I wanted to do it because I did, right? Because I could. But I'd estimate I'd easily be at 40 grand if I had to sell that with employees doing the work, my guys over here, and nobody can afford that.
I mean, that's not completely true. Number one, there are people that can and will afford it. It's just a small percentage. But like, you know, I used my existing air conditioner that I had before all of this. It's a single stage unit. it's, over 10 years old, 12 years old, and, it performs well. It's a micro channel York, which everybody hates, but it works fucking great for me, and so, sure, I'd love a different piece of equipment, but I did what I did using all parts that I had at the shop, basically.
Got it.
I mean,
Yeah.
so, and eventually I'll like to turn my piece of crap single stage York unit into an air to water chiller. So
Yeah, that's cool.
I mean, there's all kinds of ideas. What do you think, like, if you had to put a dollar amount on the work you've done to your house, Adam, what do you think the dollar amount would be for selling to a customer?
Including like the ERV and that duct system, I'd probably be in the somewhere around, give or take, 30 grand, I bet.
Yeah. And the point is that I will see a return on investment on what I actually purchased, because I didn't pay markup. I didn't pay any of that. I'm just paying the cost of the equipment. So I will see a return on investment anyway. Eventually, it's going to take a while, but I don't know that most customers are going to see a return on investment. They won't, so we can't sell it as that. We have to sell it as, this is going to be an efficient system. And I wouldn't even say energy efficient. I mean, I guess maybe energy is the right word, but efficient, right? Efficient. And we're going to improve your comfort. And, and then that way they understand, okay, this is going to cost them, this much money. But for a full-fledged inverter system with everything, like with markups and everything, you're not going to see a monetary return on investment. Like, I don't.
Yeah, I mean, I almost never talk about efficiency or anything like that. I mean, it's more about the features and benefits that an inverter brings.
Yeah.
But I also generally don't like top of the line inverters because of the proprietary control systems it locks you in. That said, I did just sell a large job that is, same sort of system you have in your house, Chris, but it's in order to utilize the modulating zoning that they have. And so that sort of is a different beast or animal, I think, or, makes a little more sense to lock yourself into a proprietary control system. But aside from that, I try not to. I much prefer things that are non-communicating inverters and let me play around with the controls to sort of get it all right, because you can do a lot more stuff with like blower speeds and stuff like that than you can with a proprietary
I was
control.
dumbfounded with the lack of control I have over blower speeds on mine. I was like, for real? I only have 3 settings? Like, that's just dumb. Like, I should be able to adjust it more.
I know recently I was talking to Dustin Cole, and he has I think he ripped it out of a job at one of the Bosch units. I don't know if it's an 18 or 20 or whatever. And his goal, he wants to try to like hack that thing so he can keep the compressor running at a higher speed as long as possible, like when he needs to dehumidify, and not just like playing with blower speeds up and down. It's like, let's push this thing to the limit. You know what I mean?
I think that
put
the
some
easiest
sort
way,
of resistor in the coil temperature sensor thingamajig that makes it think it's
making it.
Or you put a 3-phase and you put a VFD on it, and you have some sort of input that controls the 3-phase, and then you control your compressor speed based off of what you. But then you'd have to really get into programming of the.
Yeah, but that's also where, like, in my mind, and I'd like to play with a Bosch as well, but I would like to convert a Bosch as well to some air to water heat pump or whatever, where you're just, cooling down a tank, and then you do all your other magic with changing water flow to whatever device you're using, right? Like, so that is sort of my long-term vision of a perfect system kind of deal.
Oh,
yeah. This person says, have a system that can be fixed on site same day and not have to wait for parts to be ordered. Those days are getting slimmer and slimmer in the refrigeration world, in the air conditioning world. Dealers, like for instance, I made a video recently about some refrigeration system that Heatcraft has called Intelligent. And I asked the question in there and people were like, yeah, I just like simple because, you know, I don't want to have to wait 2 weeks for the parts. And my thing is I get it. I hear that. But as an intelligent contractor, I stock their parts, right? So that's the thing is, you know, the dealers sometimes are going to have the parts, you know, depending on what it is. But that's just one of the things we're learning to have to deal with is that it's getting harder and harder to get parts. They're more proprietary. It's a bummer, but that's kind of, I mean, that's the way that it's gone with cars. That's the way that it's going with everybody is proprietary stuff.
I mean, I think the future in residential, which is, you know, what I do, so it's easier for me to speak about that. But, you know, I think that we'll move to some sort of chiller system that's propane.
I agree.
And you will, you know, you will fix motors and pumps and things like that. But if something crazy goes on, you'll put a temporary unit in its place and you'll take that other unit back to your office, fix it, and then go swap it back out because you're talking, you know, a couple water lines and a couple electric hookups and you're swapped out.
And I honestly, you know, I agree. I 100% agree. That's where it's going to go because all these refrigerants are moving out the door. But here's the other thing though, too, even propane. I mean, 10 years ago, we were complaining about drilling for oil, right? We still are complaining about it. But right now, we're kind of calming down a little bit on that, right? But to process propane, right, it's a byproduct of what gas and oil and all that crap, right? They get some of it as a byproduct from that. So eventually the hippies are going to start complaining about that too, right? Because they want us to go all electric on our cars. They want to eliminate combustion engines though, and everything.
If I remember correctly, I might be mistaken, but I want to say this is not like they don't use like the byproduct propane in refrigerants. This is like lab created propane or whatever.
Oh, that's what I don't know. I just thought it was just highly purified, basically just ran through a bunch of filter dryers, no odorant ever added to it, basically taking it off the top of the tank. And the stuff that we use, well, we can ask. Yeah, I'm curious. I'd be very curious.
I mean, it has nothing to do really with it being propane or if it was some other thing. It's the global warming potential, right? You like, I mean, it's crazy low. Like,
well, and the point though,
or something.
I hear that, but the point that I'm making is that eventually they'll find another reason to attack it, and they'll come back at it. I mean, for the same thing, we went to all CO2, right? CO2 is the new thing in supermarket refrigeration, but they were complaining about CO2 a couple years ago too, you know, and all these problems. So like, it's like, okay, they calmed off on that one, right? And then now they're going.
Well, I mean, that's also just the way the world works. There's always going to be people on certain sides of whatever, right? I mean, but what I do believe though is that for sure the current change that we are facing with R454 and R32 is probably not going to last as long as 410A did.
No.
So
I heard it's probably going to be 10 years or less.
Yeah, I heard 10 to 15, but that changes, you know, who knows.
And again, I'm not an advocate for the manufacturers, but I am going to make a point, something that I've been thinking about a lot lately, is that the manufacturers, you know, that make this air conditioning equipment that had R22, right? They had plenty of time over the years between the span that they were using R22. They'd have to change their factories a little bit when a new piece of equipment came out. But a lot of the times they had the same line of equipment. They just change a few things. So their machining didn't change very much, right? So then we go to 410 and they have to start machining things differently. They have to put new equipment in their places, right? And they have to recoup those costs. And not only do they have to recoup those costs, they have to make profits, right? They're publicly traded companies. They have to generate profits to show that the business is doing good. Everybody's complaining about the price increases right now.
Well, not just that, because now the manufacturer is raising the price. So now the distributors also like to make their same margin.
Yes.
Right?
Yes.
So they're also raising their price above what it was previous just so they can make the same margin on the equipment, right?
Yeah, yeah. And I agree that, I think that there's some shady stuff happening with the price increases. That's not just simply because of the tooling and the having to redo their factories. But I think that some of those costs that have gone up are because they've had to redo their factories for these new systems, new refrigerants, new equipment, new tooling, new everything, right? And then now to have a shelf life of 10 years. So now they have to make those same profits that they made over the last 30 years, right? And show that money because now they have to retool everything in 10 years and come up with a new thing. So prices, they're going to keep going up. They're going to keep going up. And
it'll be even worse if, like, if we move to what I'm saying with like chillers and stuff like that, the cost will probably be higher as well. Yeah. So that's one of the downsides or cons of it, as well as it's like something that here in the US, at least, we're just so not used to hydronic systems in so much of the country, really.
Well, you're going to need, it's going to be a new piece of equipment inside and outside the house. And then you're going to need insulated PEX lines, right?
Yeah.
So certain houses, you probably have to rip apart drywall and this and that.
Yeah.
It'll be it's a long-term sort of thing. And that's where it sort of goes back to like my fixing houses thing, is like it needs to sort of start in new construction probably. But then the problem is, like, the people that do new construction generally don't have much of a clue, or less of a clue than some other contractors, right? And so it's going to be a little bit more of a challenge as far as like systems definitely need to be designed, right?
Yeah. And think about in that situation too, think about here, I don't know if you guys have heard about this, but in California, we're running out of land, right? We have very densely populated areas. Ironically, we're one of the biggest states and we have a crap ton of land up north, but everybody lives down south, right? In Southern California, we're running out of space. They're maxing everything out. So they're starting to go to high density housing. That's the new thing. High density housing. Everybody takes public transit, all this crap, right? Whatever. But think about high density housing. You have a high rise with 1,500 units in that high rise, right? And the retrofits that are having to happen on those, right? They may be using PTAX, they may be using some other kind of equipment, but those get even harder for them, I would imagine, to retrofit to new refrigerants, depending on what they have. Because then they're having to cut open walls. They're having to, and you can't just, depending on where the equipment, the condensers are at, if there is some, or maybe they're on a chiller or VRF, who knows? But it's interesting. The interesting thing is I don't know what Joe's trying to show us on his. Why are you showing someone sitting on a toilet?
That's Bill.
Oh,
He told us he just got back from the airport and he's sitting on the toilet.
That's much appreciated there. That's very much appreciated.
Just wanted to keep you guys posted.
You should have the tip hanging out just a little,
Oh man, that's great. Yeah, but I don't know. The cool thing is that even though we get frustrated, there's a lot of change coming in our industry, and there's a lot of money to be made with those changes, right? We as contractors, as long as we're willing to adapt and change with the times, there's more business for us.
I think the big thing is, though, residential wise, we need to. I know there's a ton. Probably the majority of residential companies, in my opinion, are probably like small mom and pop shops, right? You have like a couple big time companies in every city that are huge, white shirt type deals, but like everyone needs to charge appropriately and then reinvest in like knowledge and trying to learn these new things, because it's not just something you're going to figure out. You know what I mean? Like you gotta, yeah.
Well, you gotta care enough too, right? Like that, and that's the thing that you can't. Not everybody does, and like, I guess that's okay too, right? There's. It's sort of a challenge when there aren't there aren't like metrics of how it sort of goes back to, I forget who said, like, the grading on this new equipment being put in or whatever, like the SEER ratings or whatever, and yet they get put in on garbage duct systems and all that stuff. It would be sort of cool if there was a, company XYZ hits, the delivery or SEER rating 90+% of the time or whatever, right?
Yeah.
Like, I mean,
if there's like a badge or something, you're saying like
Well,
yeah,
but
the
I mean-
Nate badge on your arm, isn't that what that means?
Yeah, we have that here though, because we have HERS rating, right? The HERS raters are supposed to go in and verify the installation was done properly.
But they're not really checking charge, and they're not checking temperatures either.
Well, that stuff also gets like pencil whipped.
gets pencil
and
whipped,
it's also not a, like, you may get that this house passes, but do they actually, is there some database that says this HVAC contractor is consistently doing awesome job and this one isn't?
There's nobody auditing, and the HERS raters are working for the contractors. You just have to hire an independent third-party verifier to come in and make sure that you did your job right. But those guys don't get rehired if they keep failing everybody. So that's the problem.
Yeah, and Measure Quick partnered up with ACA, and ACA has a workflow in Measure Quick, but I don't think it takes it far enough. You know what I mean? Like, and nobody really knows about. That's another thing too. Is like, that's not a, that would work, and I think that would be a great thing, that workflow, if, like, they're giving out big rebates and this and that. The government's giving out rebates for high efficiency equipment. You should have to use something like that to get those rebates, where you're proving your system performance and you're proving it was designed.
But there's ways to hack that too. There's always going to be fraud. There's always going to be people messing with things. So people were talking about it in the chat. Ray just confirmed what Mike had said, is people need to care more about the trade. That's a really difficult thing to implement though. Like, you can't force people to care. So, I mean,
the problem is there's still guys making $18 or $20 an hour. And like, with the cost of living, would you really care about what you're doing if you could barely, you're not going to be able to afford an apartment at $18 an hour? Like,
where these guys get paid that little?
But at the same time, you get consumers complaining about the price of everything, right? So as a business owner, it's hard to charge appropriately for everything. And like, there's all kinds of challenges there. I mean, as far as,
I just had to have someone come out and do some work on my garage door, stuff that I probably could have done myself, but I'm just didn't have the patience. And my wife was like, please just call someone to do it. And I'm like, all right, I'll call the guy. And it's like,
you can kill yourself if you mess with those springs and you don't.
That's why that was the one thing I was going to replace, because I had a bad garage door opener and I knew it was going bad. I've been telling my wife, I'm like, that garage door is going bad, or the opener is going bad. I could hear it. And then, so when it finally failed on us, I was like, oh shit, I wanted to change that. But then I disengaged the garage door opener. I went to go lift the garage door and I'm like, something's wrong. I can't lift, like, I can lift it, but I had to put like 80 pounds of force to lift that damn door. Like, I'm like, something's not right here, So that's when I was like, okay, I need to get new springs. And I'm like, I know I can change the springs. I mean, you just got to use rods. I deal with that kind of stuff. I can do it. You can get hurt, but you can do it carefully, but I don't know where to get the springs. I really didn't want to go through that dicking around on Amazon crap. And so then I called the guy and it's like, okay, yeah. So,
I don't know if I buy Amazon garage springs.
That's true.
You buy some Alibaba freaking Temu garage.
Yeah.
He's going to be in his garage and ting right off the head.
Yeah. Right in the freaking funk, hit you in the head. But I had to pay a company to come out, and it was like, fuck, man, that was a lot of money, and it's like, geez, dude.
Everything's expensive.
And that was the thing too. I was in my head doing the math. I'm like, okay, the garage door openers, I can go pick one up for $400, like the one that I bought, right? But he's got to make a profit. So I'm like, okay, here and there. And there was a little bit of fudge in this, and it's like he had flat rate pricing, right? Because, hey, I want all new moldings around my doors, both of them, because the moldings are all messed up, and the under seals, I want those. And it's like, okay, it was basically, I could tell by doing the math. I'm like, okay, this isn't just based off of a markup. This is a, Moldings are $400. Moldings are this, whatever it may be, you know. And it was just like, okay, yeah, that was pretty expensive. And
Yeah,
you know,
so
but, I mean, it is what it is.
the comment that Joe posted on the screen by David, I actually met David at the summit, the NCI summit. He's an awesome dude. He's making his own, I think, N and M filter cabinet. So you could use 2-inch, I believe, or 1-inch filters, and it's like a really nice airtight cabinet that he's like manufacturing in his own shop right now. But he was saying ASHRAE 221. ASHRAE 221 is basically taking everything into effect, like temperatures and this and that. And that's like an NCI standard. That's something that was born from National Comfort Institute, which was pretty cool.
You know, another thing that we don't often, I don't think, is really addressed or thought about when we're talking about fixing the home, you know, the accessories we put on our home that damage our indoor air quality and comfort too. For instance, at my house, I've been dealing with something. I have one of those stupid doggy doors you put in a sliding glass door, right? One of the temporary ones you just put in the door, you put it on, it's single pane glass. I could literally stand in front of that doggy door, feel the heat just coming through, right? And then move over 6 inches to the other slider that's dual pane, blah, 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 all this crap. And you don't feel anything, you know? And for instance, today we have high winds at my house, and right around my sliding glass door, sand is everywhere, right? Because the winds are blowing, dirt's blowing. So we as consumers go and buy, hey, I need a doggy door, right? You go and buy an insert because you don't want to cut a hole in your wall. And then maybe they don't realize how much that's damaging their home. So then let's add on other things. They're going to buy, you know, something for their windows, or who knows, you know? So I don't know, maybe a standard of some sort where people understand that, you know, if you go with this, how much it's going to mess things up.
That kind of reminded me of something that I did in my house before I started diving into building science. And, you know, like, you guys know what like shiplap is, right?
Yeah.
I did something kind of like shiplap, where it's just like the 1x6 pieces of wood. And I did like an entire wall in the bathroom with no drywall or anything behind it. And it was the plumbing wall.
Oh, that.
So I made that entire wall like a freaking like Swiss cheese, like leaky as heck. You know what I mean? And I didn't realize what I was doing. I think a lot of people, when they're making small little improvements on their house, they have no clue how they're impacting their house as a whole. You know?
Yep. 100%. You know,
Well,
like I was telling,
complex in ways that a lot of people don't think about, right? I mean, like, it's easy to get caught in the trap of just, you know, doing whatever pleases you in the moment kind of thing, or, you know, you want that shiplap wall because of the way it looks or whatever, versus all these other impacts. And it's even if you are smart and try to think about all the stuff, you'll miss things or whatever, right? Because it all just interacts in such a complex way that is beyond most of our comprehensions. You know what I mean?
100%.
Like,
well, one thing I noticed with my new system is I have an awesome MERV 16 filter, right? But it's a smaller system. I'm moving less airflow. So each room has less air changes, right? So I noticed, like, I thought by tightening up my house and getting a better filter system and a tight duct system, I was going to drastically improve the dust in the house. I have dogs. My dogs bring in a ton of dust. They're rolling around outside and everything else. But I'm having a problem keeping the dirt and dust entrained in the air long enough to hit that filter. So, like, I was thinking now, because my system's in my basement, I almost want to run a separate small duct system in the attic and be able to just move more air and filter more air, you know what I mean? And have a couple different speeds where I can ramp up the fan in that.
And I would agree that I'm kind of in the same thing. I'm noticing dust like crazy, dude. And it's my dogs. I mean, you know, but it's just like, oh, it's ridiculous, dude.
Mine has gone down for sure, but that's because I run much higher airflow than I used to. And I trap a lot of stuff in my filters. I mean, it's they're pretty nasty looking when it's time to replace them. And so
I would say that I do trap a lot in my filters, but I also have return air grills on the ground, right? And I have a closet unit. So I am pulling a lot of crap. But most of the stuff I see in there is dog hair, my wife and my daughter's hair, and some dust. I mean, there is some, you know, but most of it's hair. And it is making it up to the equipment because, interestingly enough, the cavity underneath the filter is not all dusty, and it's not all full of hair. So it's making it through the grill and up to the filters. The suction or the pull is there, but the rest of the house, though, like you guys are explaining, yeah, I got dust everywhere on the floors in the house, you know, because possibly we're not moving that air, and my dogs are just pain in the asses. So
the sacrifices you make for dogs.
Oh my gosh, animals in general. We've been to the vet so many times in the last, my wife has, I should say, I haven't, in the last couple months. It's ridiculous, dude. I love my animals, but I'm no more animals. And my wife agrees too. We're done with animals when these ones are done. We're just fucking done. So
I want to know the cost. They're talking about, you guys were talking about VRFs and chat VRFs, the cost difference, because I went to go change a Lennox programmable thermostat for a VRF in a building. And on top of that, changing that to like $800, probably our cost. On top of that, I had to reprogram all 150 of them because apparently this was dumped on me. But because VRF and us kind of separate, but anyways, this was dumped on me. They were having trouble with, I guess, sweating ducts in the summertime. So I guess they got Lennox involved, and they're telling us to do some different things on the thermostat. So I went to all 150 of them. Anyways, my point is 150 thermostats are like over $1,000. All the boxes, coils, fans, I don't know what else. Like, the cost must be way more than
this
a
was
VAV box with a rooftop unit.
Right, but this was explained, like Chris Hughes explained this to me because his family, Hughes Mechanical, they were in like deep with the Daikin VRV game, right? And there's like government money that backs that stuff. And if you have like a building that's like an energy hog in that, and you have old equipment and the equipment needs to be changed anyways, you can play games where they give you a big rebate check, and then it's like there's a tax break on top of it.
True.
To do it. True. So like the out of pocket, it's almost like it doesn't make sense not to do it.
I hope so.
One of my uncles made a lot of money by basically he would give big companies the equipment for free, do all the labor and everything, and then get a percentage of that money over the course of, you know, a certain amount of years or whatever, and made a heck of a lot of money doing all of that.
You're saying like the percentage of the energy savings?
Percentage of the energy savings, and he would get the tax credits and all of that stuff.
Oh,
and so it was like, you know, it was for big, you know, GEs and Procter and Gamble's and like these giant companies that because, you know, when you're talking big industrial plants and stuff like that that use tons of energy, like even small improvements can be significant.
You know,
yeah, even if you think about it, even one rooftop, let's say you have a couple filters, whatever filters, or 6 of them, whatever, and some VAV boxes. Then you have filters. Imagine the expense on the filters of all those boxes, all those VRF boxes, like 100 and something boxes in your ceiling space. Just the filters alone, look how much that money that is. It's fucking nuts, man.
Yeah, but you got to think about it this way, though, Joe. Like you're changing the usage of the filters because now everything is kind of zoned, right? You're not using a couple monster rooftop units that are running nonstop. You have like all these little units that like turn on and turn off.
Yeah, for different temperatures, but you can still do the same thing rooftop with VAV boxes, you know, something like that. I know it's not as precise for the different climates, heating and cooling, but you know,
it's different though, like because the thing in big commercial buildings or whatever is you have certain areas that need heat and certain areas that need cooling at the same time, and that's where VRV or VRF makes some sort of sense.
Because everybody
wants I think that could also be done with hydronics or whatever, like VAVs and the old school, like, you know, they just reheat areas or stuff like that doesn't make as much sense in my mind, right? Like so I can understand the VRV or VRF. I don't know that it's the best solution, but it does make some more sense than VAVs and
Especially,
stuff like that.
you're right.
So-
Especially if it's a warehouse like this is, and they made all these cubicles, offices. So yes, you have different climates for sure.
Fucking
My-
Kramer just
my-
entered my room right now. My dog, the door just swung open and my fucking dog just walks in like, hey, what's
Aw.
up? Come here, dude. Pain in the
Neil
ass.
was saying that filters aren't there to clean the house; they're there for the equipment. I agree with that on the 1-inch filters, but once you start getting into like, the higher MERV rating filters, like the one I have in my house, absolutely is for cleaning the air, 100%. It's a MERV 16 filter. That's what it's for.
Yeah, I would agree. Its primary job is to keep the equipment clean, but at the same time, like it definitely does something to the air quality.
Right.
I mean,
Real quick, I know we're already at an hour. I know we got to wrap it up, but I one question I wanted to see, because Housh, you were just saying that you could do the same thing with like, when we're like VRF, like transferring heat from one space to another when you have one room heating, another room cooling. How would that work? Paint a picture with hydronics.
you would have to have a hydronic system that is basically for some reason I have a brain fart of what they call them, but it's a heat recovery chiller. So essentially it'd be like a 4-pipe deal where you have 2 pipes coming out of the chiller that are cold water and 2 pipes that are hot water and going different places. So it's basically the same concept as VRV or VRF.
It's just water.
Just water instead. And so I mean, yeah, so it's not much different. The difference would be that you can keep all the refrigerant and all that stuff smaller because you're not running it through to the 150 indoor units or whatever, and keep all that stuff outside and just run water through places. So
yeah, I think that's probably the one major downside for VRF, right? Is like the amount of refrigerant. If you have a leak, you're leaking a lot.
And the amount of, like, I think piping you probably can't get away from, but like at least with hydronics, and as long as you don't need super hot water, you can run PEX, which is fairly cheap and not it's fairly reliable, I would say,
and easy to use. Yeah, better than copper.
Yeah.
It's funny too, because one of the settings they told us to put is make sure you have fans always on low speed, never off, always air going across the coils in heating or cooling. That was one of the settings you guys were talking about earlier about fan always running. But anyways,
that's for VRF.
Yeah.
Is that because they're monitoring the temperature in the return?
No, they were, I guess, reading the notes, ducts were sweating. And nobody decided yet to take some measurements and dew point measurements and humidity, because I think seen in the recommended solutions after, like in one of the numbers, there's like, if condensation continues to form exterior duct surface, then obtain readings of the following: dry bulb temperature, RH, or wet bulb of the air in the ceiling space adjacent to the ducts, surface temperature of the ducts. That's recommended if it still happens after these settings.
Well, you're either gonna change the surface temperature of the ducts or the air around it, right?
Right.
You're gonna try
the
relative humidity. You're gonna
drop which running the fan all the time in the off cycle isn't going to change any of those.
Isn't going to help, right? And it's funny you said that, because I was telling the guy I was working with today, I'm like, dude, literally, I think this is going to make it worse in the summertime. It's hard to see it now because we're in the winter now. This should have been done in the summertime. But anyways, we're going to see next summer. But for some reason, occupy sensor off.
They're trying to save face and they're throwing shit at the wall right now. To just
occupy sensor. It might be affecting. Might be conflicting with the BES. So turn occupy sensor off. Auto dry mode. Put it on. 50%. It's already targeted by default. Humidity. And,
yeah, but they could be onto something
static
about
pressure.
the air temperature, space, and the relative humidity. Who knows if there's air leaking in anywhere where they're getting infiltration or whatever humid
Where
air
those were
in that
leaking.
space above, and what's the temperature of the ducts? Like that would probably be a good thing for next summer to do some data logging in this.
Oh, absolutely, that'd be great. And which ones are, like you said, which ones are condensing? Wherever they are, it's probably close to the garage, maybe the warehouse. Who knows? Outside wall. Who knows? Yeah, it's gonna be interesting.
Yeah.
Well, the other good thing about like my coil bypass and all that stuff is like my supply air temperature is generally only 5 to 7 degrees cooler than my return air temperature.
Oh, cool.
And so it does help eliminate duct sweating or reduce the possibilities of duct sweating some by raising that temperature.
So is that a 13 SEER condenser?
Yes.
Have you run Measure Quick on it and see how efficient you're running with those kind of airflow numbers?
Yeah, but I couldn't recall what it is. I mean, it was I think a lot of times with Measure Quick or whatever, you'll get kind of higher SEER ratings than what it's rated, because it's not a seasonal efficiency like they're rated at or whatever.
Yeah. It's like
so I feel like I was getting 14 SEER or something, but it's been so long since I actually ran it and paid attention to those.
If I remember
numbers.
right, too, the thing about Measure Quick, and maybe I'm wrong, you guys can correct me, but the thing about doing the SEER rating and the efficiency rating with Measure Quick is that you're taking a one-time reading and you're not seeing a dynamic reading, right? Because the meter takes it once and it logs it and it says this is your SEER rating. Is that not correct? It's not sitting there looking at it like it's looking at a superheat number that's going up and down.
It'll change.
Does it? Okay.
But your power consumption will be
one time,
but
yeah.
You could monitor it, I guess, but I don't think that it fluctuates all that much for
That's true. If it's not ramping up and ramping down.
Yeah, the rest of it, as long as you leave your probes on and active, like the only thing you actually have to capture is the electrical, right? Where you actually have to lock it in.
I have the hardest time capturing electrical with the freaking redfish too. I think it's a pain in the butt for me, but I don't know. I'm probably doing something wrong. I don't do it enough, and I've never watched a video on how to do it, so guaranteed I'm doing it wrong.
David, I'm just started doing all the VRF boxes, doing the filters now, giving the guy a hand, and most of them, I believe, it looks like they are getting the return from the actual rooms. They're ducted, from what I see. There could be some that are probably using the space, but I believe they put a duct to the ceiling for that space. We'll see. We're gonna find out. It's gonna be interesting. Oh, and static pressure. They told us to raise up the static pressure. I raised it says from 0.24 to 0.35 because it was set to really low, like 0.02 or something like that. Anyways, and that's pretty much it. The settings.
So that if it works if it's similar to Daikin, that's all that's going to do is increase the airflow, which will decrease the dehumidification.
Yeah, it's weird. I don't know. That's what they suggested.
But you'll increase the air temperature will be warmer running through the ducts, so you might.
True, which would help. Yep.
So, anyway,
the problem with all the VRV and VRF and perhaps it's my misunderstanding of it too, would be that if they work similar to all the other mini splits that I'm used to, they just typically don't do great at dehumidification. I know certain brands are better than others, but that always becomes a challenge, I think, on those systems.
I have like the super high end Daikin unit for my house, which is the Sky Air, but it doesn't, for dehumidification, it doesn't ramp the outdoor compressor and slow down the indoor airflow. And all it does is overcool to dehumidify, which I think, I want your opinion real quick. I know we're getting way over here, but I think overcooling to dehumidify is kind of a silly thing to do. And
Yeah, I think we should add more heat.
yeah, I mean, if you think about what's happening, if you're overcooling to dehumidify, you could do it by like what, 1, 2, or 3 degrees. So like as you're overcooling, you have a target relative humidity, but the colder it gets, you're changing how much relative humidity there is in the air. And then once you hit that max set point, you're like 2 or 3 degrees over, you overshot your target. Now your equipment shuts off. And now you're bringing in, you have a longer off cycle. So
Yeah, but you'll cycle back on humidity. I mean, it basically just changes your set point to lower, right? Like, so it's going to cycle off and back on probably
but like
similar.
your dehumidification set point is kind of unrealistic if you're changing your sensible set point by 3 degrees.
Correct. Yeah. Well, I mean, I definitely think driving it off of relative humidity, or the fact that we in the industry and or consumers focus on relative humidity so much, is sort of silly, but that's what the gods decided to do, apparently, rather than use dew point or something that would be wiser.
Keep in mind that Navac has rebranded that name as Dew Bulb. Okay. So that's called Dew Bulb. They released a new tool, a new psychrometer. I seen a picture and they call it Dew Bulb on there. Right on the thing, it says Dew Bulb. It's like, oh, okay, cool. They're coming out with a new name. It's not Dew Point anymore. It's Dew Bulb.
Wow. Interesting.
It's funny, but all right. Well, I think it's time we wrap this up.
Yeah.
Okay, bye.